हॅलो फ्रेंड्स, वेलकम टू सपनाज होमस्कूलिंग चॅनल. नमस्कार विद्यार्थी मित्र मैत्रिणींनो, स्वागत आहे तुम्हा सर्वांचं सपनाज होमस्कूलिंग या चॅनलमध्ये. आज आपण इयत्ता 10वीचं सायन्स अँड टेक्नॉलॉजीचा 10th लेसन स्पेस मिशनची एक्सरसाइज बघत आहोत. चला आपल्या व्हिडिओला सुरुवात करूया. फर्स्ट क्वेश्चन आहे, फिल इन द ब्लँक्स अँड एक्सप्लेन द स्टेटमेंट्स विथ द रिझनिंग. If the height of the orbit of a satellite from the Earth's surface is increased, the tangential velocity of the satellite will decrease. Explanation: this can be easily inferred from the formula of critical of tangential velocity. B. The initial velocity during launching of the Mangalyaan must be greater than Vc is equal to in root gm upon r plus h of the Earth. Explanation: the initial velocity during launching of the Mangalyaan must be greater than the escape velocity of the Earth. Question 2. State with reasons whether the following sentences are true or false. A. If a spacecraft has to be sent away from the influence of Earth's gravitational field, its velocity must be less than the escape velocity. Answer: the statement is false. This is because the minimum velocity with which the spacecraft must be projected so that it escapes the Earth's gravitational pull is known as escape velocity. So the initial velocity of the spacecraft must be greater than or equal to escape velocity of Earth. B. The escape velocity on the moon is less than that on the Earth. Answer: escape velocity on the planet is given as V escape is equal to in root 2 gm upon r is equal to in root 2 gr. Since acceleration due to gravity on moon is 1/6 of the Earth, thus the escape velocity on the moon is less than that on the Earth. Hence, the statement is true. C. A satellite needs a specific velocity to revolve in a specific orbit. Answer: the specific velocity with which the satellite revolves around a planet is known as a critical velocity. It is given as Vc is equal to in root gm upon r plus h. So it can be observed that the critical velocity of a satellite changes depending on the height of the orbit of a satellite changes orbit from the surface of a planet. Thus, to revolve in a specific orbit, a satellite would require specific velocity. Hence, the statement is true. पुढे आहे D. If the height of the orbit of a satellite increases, its velocity must also increase. Answer: the specific velocity with which the satellite revolves around a planet is known as critical velocity. It is given as Vc is equal to in root gm upon r plus h. So, we see that as the height of the orbit of a satellite increases, its velocity must decreases. Hence, the statement is false. Question 3. Answer the following questions. A. What is meant by an artificial satellite? How are the satellites classified based on their functions? Answer: a man-made object orbiting the Earth or any other planet is called an artificial satellite. Satellite works on the solar energy and hence photovoltaic panels are attached on both sides of the satellite which look like wings. Satellites are also installed with various transmitters and other equipment to receive and transmit signals between the Earth and the satellites. Classification of satellites depending on their functions. First, weather satellites. Weather satellites collects the information regarding weather conditions of the region. It records temperature, air pressure, wind direction, humidity, cloud cover, etc. This information is sent to the Space Research Station on the Earth, and then with this information, weather forecast is made. Communication satellite. In order to establish communication between different places on the Earth through mobile phones or computer-assisted internet, the communication satellites are used. Many artificial satellites are placed at various locations on Earth's orbit, are well interconnected and help us to communicate with any place from anywhere, at any time, and in any form, including voicemail, email, photograph, audio, mail, etc. Third, Broadcasting satellite. Broadcasting satellites are used to transmit various radio and television programs and even live programs from any place on the earth to any other place. As a result, one can have access to information about current incidents, events, programs, sports, and other events right from his drawing room with these satellites. Navigation satellite. Navigation satellite assists the surface, water, air transportation and coordinate their busy schedule. This satellite also assists the user with current live map as well as real-time traffic conditions. 5. Military satellites. Every sovereign nation needs to keep the real information about the borders. Satellites help to monitor all movements of neighboring countries or enemy countries. Military satellites also help guide to the missile effectively. 6. Earth observation satellite. These satellites observe and provide the real-time information about the Earth. The satellite also help us to collect information about the resources, their management, continuous observation about a natural phenomenon and the change within it. B. What is meant by the orbit of a satellite? On what basis and how they are orbits of artificial satellites classified? Answer. An orbit is a specific path or trajectory around the planet in which a satellite revolves. Depending on the height of the satellite's orbit revolves the Earth's surface. The satellite orbits are classified as below. High Earth orbits, higher from the Earth's surface, 3578 km. If the height of the satellite's orbit above the Earth's surface is greater than or equal to 35,780 km, the orbit is called high Earth orbit. Medium Earth orbit. If the height of the satellite orbit around the Earth's surface is in between 2000 km and 35,780 km, the orbits are called medium Earth orbits. Low Earth orbits. If the height of the satellite orbit above the Earth's surface is in between 180 km and 200 km, the orbits are called low Earth orbits. C. Why are geostationary satellites not useful for studies of polar regions? The geostationary satellites orbit above the equator, thus these are not useful for studies of polar regions. D. What is meant by satellite launches vehicle? Explain the satellite launch vehicle developed by ISRO with the help of a schematic diagram. Answer. Satellite launch vehicle are used to place the satellites in their specific orbits. The structure of a polar satellite launch vehicle PSLV developed by ISRO is shown below. It is a vehicle with 4 stages using solid and liquid fuels. The weight of the vehicle decreases after each stage because of consumption of fuel at that stage and detachment of that stage. Example, the empty tank from its body. Thus, the vehicle moves with higher speed after every stage. So, अशा प्रकारे ही त्याची रचना आहे. E. Why it is beneficial to use satellite launch vehicle made of more than one stage? Answer. The major portion of weight in satellite launch vehicle is contributed by fuel. Thus, vehicles have to carry a large weight of fuel during their course of journey. To overcome this problem of launch vehicle carrying heavy loads during its entire journey, it is provided with more than one stage. Because of this, the weight of the vehicle can be reduced by step after its launching. For example, consider a launch vehicle having 2 stages. For launching the vehicle, the fuel and the engine in the first stage are used to impart a specific velocity to the vehicle and takes it to a certain height. Once the fuel is in this first stage is exhausted, the empty full fuel tank and the engine are detached from the main body of the vehicle and fall either into a sea or into unpopulated land. As the fuel in the first stage is exhausted, the fuel is in the second stage is ignited. However, the vehicle now contains only one stage. The vehicle can move with higher speed as the weight has reduced. Question 4. Complete the following table. Answer. Question 5. Solve the following problems. A. If mass of a planet is 8 times the mass of the Earth and its radius is twice of the radius of the Earth, What will the escape velocity for the planet? Answer given. First, the mass of the planet M is 8 times the mass of the Earth. Example, 8 into 6 into 10 raised to 24 kg. Second, the radius of the planet R is twice the radius of the Earth. Example, 2 into 6.4 into 10 raised to 6 kilometer. Answer 3. G is equal to 6.67 into 10 raised to minus 11 nm square into kg square. Escape velocity for that planet. So escape velocity is equal to in root 2 gm upon r is equal to 2 into 6.67 into 10 raised to minus 11 nm square into kg square into 8 into 6 into 10 raised to 24 kg upon 2 into 6.4 into 10 raised to 6 meter is equal to 6.67 into 10 raised to 13 into 8 into 6 upon 64 into 10 raised to 5 meter per second is equal to in root 6 into 67 into 3 upon 4 into 10 raised to 8 meter per second is equal to in root 20.0.1 upon 4 into 10 raised to 4 meter per second is equal to 2 into 237 into 10 raised to 4 meter per second is equal to 22 into 22.37 kilometer per second. B. How much time would a satellite in an orbit at a height of 35,780 km above the Earth's surface take to complete one revolution around the Earth if the mass of the Earth were 4 times its original mass? B. Answer given. R. Earth is equal to 64,000 km is equal to 6.4 into 10 raised to 6 meter. M. Mass of the Earth is 6 into 10 raised to 24 kg. So m dash is equal to 4m is equal to 4 into 6 into 10 raised to 24 kg. Height is equal to 35,780 km. 3.578 into 10 raised to 7 meter is equal to 35.8 into 10 raised to 6 meter. G is equal to 6.67 into 10 raised to minus 11 nm square into kg square. So T is equal to what? The time that the satellite would take to complete one revolution around the Earth is T is equal to 2 pi in bracket r plus h upon Vc. Now Vc is equal to in root gm upon r plus h. T is equal to 2 pi in bracket r plus h upon in root gm dash into in bracket r plus h is equal to 2 pi upon in root gm into r plus h in 3 by 2 is equal to 2 pi in bracket 6.4 into 10 raised to 6 meter plus 35.78 into 10 raised to 6 meter bracket complete 3 by 2 upon in root 6.67 into 10 raised to minus 11 nm square into kg square into 4 into 6 into 24 raised to kg is equal to 2 pi in bracket 42.18 into 10 raised to 6 bracket square 3 by 2 upon in root 6.67 into 24 into 10 raised to 13 seconds is equal to 2 pi up in root 42.18 into 10 raised to 18 upon in root 6.67 into 22.4 into 10 raised to 14 seconds is equal to 2 into 3.142 into in root 42.18 root into 10 raised to 4 upon 6.67 into 2.4 seconds approx 4.303 into 10 raised to 4 upon 36,000 hours approx 3.3 into 10 raised to 4 seconds approx 11.95 hours or 11 hours 57 minutes to 10 seconds. See, if the height of a satellite completing one revolution around the Earth is in 10 seconds is h1 meters, then what would be height of a satellite taking 2 root 2 t seconds for one revolution? Given time t seconds, height h1, let us assume the height of the satellite completing one revolution in 2 root 2 t seconds as h2. T is equal to 2 pi r upon Vc. Example, T is equal to 2 pi in bracket r plus h1 upon in root gm upon r plus h1. T is equal to 2 pi is equal to in bracket r plus h1 cube upon gm. It's the first equation है, पहले equation आहे. And 2 root 2t is equal to 2 pi in root r plus h2 cube upon gm हे दूसरं equation आहे. From equation 1 and 2, 2 pi is t upon 2 root t is equal to 2 pi in root r plus h1 cube upon gm upon in root r plus h2 cube upon gm. So 1 upon in root 8, it is equal to in root r plus h1 cube upon r in root r plus h2 cube. So 1 upon 2 is equal to r plus h2 upon r plus h2. So r plus h2 is equal to 2r plus h1. That's why h2 is equal to r plus 2h1. थँक यू सो मच फॉर वॉचिंग अ व्हिडिओ. विद्यार्थी मित्रांनो, जर हा व्हिडिओ आवडला असेल तर लाईक करा, तुमच्या विद्यार्थी मित्रमैत्रिणींना शेअर करा. तुम्हाला याच्यात काही अडचण असेल तर आम्हाला कमेंटमध्ये नक्की कळवा. चॅनलला सबस्क्राईब करा. धन्यवाद.